So write this first one down. The other ones will be on the next page.
I put something off.
Okay, so you're writing distance formula between 2 points using coordinates. That's in parentheses. There should be a comma like in between this, but my ones look like commas. So it's x1, and then there should be a comma right here. Okay, and then y1. Okay, and then we would add the other one, x2 and y2, and then we plug it into this formula. You've actually had this a while back. Then this just reads as x2 minus x1 squared plus y2 minus y1 squared. And then all of that, after you simplify it, is the square root. Okay, if you're still writing, continue writing. So some of the questions, and I can't guarantee that it won't appear like in the exercise, but most of the equations, you don't have to find the distance of all the sides, okay? And some of these are actually easier if you just draw a sketch, and so you know what you're looking for, because you can generally just look at like the x's, and because it's a straight up and down, okay, that you could find what that distance is. So it's easy to find it when it's straight up and down or horizontal left to right, because you can just count over spaces in between those points, what it would be like on a number line or on a graph. But when it's at an angle, it's harder to do that distance because it goes in between some half marks and 3/4 marks, so that you wouldn't have to use that. Okay. But most of the time you won't have to. So I just want to make sure that you've got that. Okay, these next ones you probably remember maybe from 4th grade. I don't know. I don't know when you learned these. I know when I looked them up on Khan, it was listed as 3rd grade. Oops, sorry. Okay, so area of a square. Okay, it's just the side, whatever the side lengths are, you're going to square it. Okay. Area of a rectangle is length times width. And on that, it really doesn't matter which one's which, we just know. We're going to multiply one by the other. Okay, and then perimeter, most of the time I think you'll remember it as a sum of all the sides. Okay, so you'll just need to know on a square, you would have 4 of them, right, that are all the same. But on a rectangle, you would have 2 that are considered the length and 2 that are considered the width. So on perimeter, you could have 2, you find the length and the width, add them together, and then multiply it times 2, or just do the sum of all the sides. Okay. Okay, and then the last 2. So area of a parallelogram, so it's base times height. Okay, so height is not like the rectangle, it's not the outside. Okay, remember that would be over here. It's going to be the one that forms 90 with the side. So we have to refer back to triangles again. Okay, that doesn't go away. Okay, and then area of a triangle is 1/2 base times height, or you can go base times height divided by 2. Do the same thing. And again, height has to be the one that goes from one angle to the other side and forms 90 degrees. So height always must be 90 degrees with the side. Okay, so a lot of these will not have drawings to them. So write this down and then we'll draw and sketch what it's talking about. So the coordinates of the 4 vertices of a parallelogram are a -3, 5, -110, 5, 10, and 3, 5. And then we're finding area. Okay, so what is the formula that you just wrote for parallelogram to find area? It's base times height. Okay, so a parallelogram, so that would look like, we don't know what kind of parallelogram it is, but we're just going to assume it's something like this. We're going to graph it. So base, this one, and then height would need to be the one that goes from one corner down to the other side and forms 90 degrees with it. Okay, so we have to define that. So we can't just go this times whatever's on the outside, because we don't know if it's a rectangle or a square, okay? Because those are parallelograms as well. Okay, so graphing-wise, and this is what I was talking about, I don't think you necessarily need to use that formula, as long as you can kind of like draw a sketch and know what numbers you're working with, because you don't need to do every single side and find the distance on all of them, okay? And go through all of those steps. So if I were to graph this, remember these x comes first, y, x, y, x, y. So if I did a negative 3, 5, and again, I'm not going to do an exact graph. I just know that negative 3 would be someplace over here, and maybe 5 is like right here. Okay, so that would be my negative 3, 5. Okay, if I did negative 1, 10, well, negative 3 was right there, negative 1, and then I'll say 10 is up here. Okay, so negative 1, 10. Okay, and then 5, so over 5, so it's going over 5, and up 10. Okay, and just because I know it's parallelogram, I'm just going to make it look like parallelogram. That would be my 3, 5. Okay, so I need to find, pretend like that's a vertical line, but I have a graph. I need to find this bottom number here. Okay, so that's representing the x or the y. Going this way. X, right? X is left and right, y is up and down. So I need to find the distance in between here and here. So you can think of, well, I'm coming over, right, from a negative 3 to 0, and then plus 3. So the distance in between that would be what? 6, right? So if you didn't, then we just know that this is the x value, which in the formula, we subtract them, right? Which would give me a negative 6. And then we square it. Negative 6 times a negative 6 would be 36. And then that last part of that formula, after you simplified everything underneath there, was to do what with 36? You look at your distance formula. Because we don't have to find both the x and the y. Square root. Okay. So this would be 6, which was just what you just said. If you can see that it's a negative 3 and 3, I just need to find the distance in between those points. Okay. So, but that's where that distance formula would come in. I don't have to find the distance of the y, because I'm not going up, I'm going left and right. Okay, so that would be 6. Okay, so we found the bottom part, right? So I'm going to re-sketch my parallelogram here. Okay, so I found this to be 6. So now I need to find from one of my corners down to the other side. So if that's coming straight down, I'm not finding the x this time, I'm finding the y. Okay, so visually what we're looking at, and you can do it on different parts of it, but I'm looking at this part right here. Okay, so I'm trying to find the distance between here and here, which is the y's. What is the distance between 5 and 10? 5, right? Okay, so if not, then you would go through your square root thing, but I think that's easier. So that's why I'm saying if you sketch it versus going through the formula, that's going to be easier on you. Okay, so the distance between the y's, because that's counting up. Okay, distance between 5 and 10 was 5. Okay, so that was 6. This was our 5. Okay, formula for parallelogram was to do what with those two numbers? Base times height. So our base was 6, our height was 5, 30. So our answer is 30. And that was taking 6 times the base times 5. We good? Yes. Yeah. Okay. Well, when we subtracted this one, if that confused you, when we subtract the y's, okay, 5 minus 10 would give you a negative 5, just like what we did there. Square it, which would be negative 5 times negative 5 is 25. Taking the square root of 25 would make it 5. So it's back to that.
The numbers, since we were finding x, so since they're both 3, is that why we did that?
So you were supposed to subtract. So if you go back to your formulas to subtract the x's and subtract the y's from each other, and then square it. So this is a negative 3. That's your x, right? So a negative 3 minus 3. Okay, which is in your formula, and then we square it. So negative 3 minus 3 is a negative 6, and negative 6 times negative 6 would be a positive 36, and square root of it, which takes you back to 6. If you wanted to start with this one, you could, because you could go 3 minus the other one, which is a negative 3. Well, 3 minus negative 3 needs change to, right, which would be 6, and squaring your 6 would give you 36. Yes?
The order of the coordinates always going to be like bottom one corner on top of corner on top right, and bottom right?
Like the first two?
Yeah.
I think if, I might be, we'll check when we do one of these on here. So yeah, you could always just start with the first two coordinates. He's talking about the, I think that's what you're talking about. And you can choose it from any of them. So like you could have found the distance from here to here, right? And it still should have been the same thing. Okay, because if it changes length, then it's no longer a parallelogram if that one's longer than the other one that's down the bottom. So I would say yes, you could do that. So you're finding the distance of your y's. Okay, and then finding the distance of your x's. And then those are your 2. That was negative 3. Yeah. Yeah.
If you took like when you found the height, you had that little line. If
Uh-huh.
you took that like left triangle out and you put it to the right side, would that make a square? Or a
Yeah, if you're taking it over to here, you mean?
Yeah.
Yeah.
So that's why it's base times height.
Yeah.
Okay.
Yeah. And I think that was in con for your last section solving, which some people did use that for solving for something on the test. I remember that. I'm like, why are you using that?
For the top one, how would you do that? Because if you minus 10 minus 10, then you just.
That's the y-axis.
Huh?
That's the y-axis. And for the x-axis.
Oh, yeah, sorry.
Yeah.
You only find the x-axis?
If it's straight across.
If it's straight across, yeah. And all of these, I think all of these are straight across that I've noticed. So we'll try one together when we get done with the notes, but. Okay. Next one, 40. And I couldn't do a fraction thing on here, so that's why it's smaller. So find the perimeter of a rectangle with a length of 11 1/4 feet and the width of 5 1/2 feet. So if it's a fraction question, I want your answers in a fraction answer. So some of you know how to convert some of these to decimals, and I'm fine with that. Just make sure when you go to write your answers, change it back, okay? That way I'm not having to read 10 different ways to write things. You're still writing these, I just want to talk about a couple of things. So there's multiple ways to do these. So perimeter is the sum of all the sides, okay? Some of you will add the 2 opposite sides that are equal to each other and be able to reduce it down. That's what I'm saying, there's multiple ways to do it. So the 5 1/2, okay, I would say that this is 5 1/2, and that means that this one is 5 1/2. If this one's 11 1/4, that means this one is 11 1/4. So one way to do it would be just add all the way around, okay? The other way was to show that we know we have 2 that are 5 1/2 and 2 that are 11 1/4. Okay, and I'm only doing this just because I want to remind you how to add with fractions and multiply with fractions, because not all of these will be 0.25 and 0.5 when you're doing it in your calculator, so that you know how to get back to something that's not terminating decimal, okay? All right, so we've got 11 1/4. This is the formula we're going to try just to make sure that you guys know how to do this. Okay, we have our length was that, and my width was 5 1/2, right? Yeah, 5 1/2. Okay, and I know I have 2 of those, and I have 2 of those, so that's why that 2 is on the outside. Okay, so order of operations, we would do parentheses first. So 11 1/4 and 5 1/2. Before I can combine them, I have to have a what? Common denominator. So I would need to multiply this by 2 and this one by 2. Okay, so now I have 11 1/4 plus 5 2/4. Okay, so 11 and 5 would give me 16, and I'm going to add my numerators. You don't add your denominators, they stay the same. Okay, so that would be 3/4. And again, we know that represents as a decimal as 0.75, right? So some of these, it probably is easier to do in your calculator with a decimal, but just make sure in the end, If you still have a decimal in your calculator, convert it back to the fraction. Yes? No, we're adding. We will be. We're not done yet. I'm just doing the order of operations. So the order of operations is parentheses first. So we're adding what's inside the parentheses right now. Okay, so now we're going to multiply. So our rule on multiplying is I need to change this mixed number into an improper fraction. Okay? Or you would know that you have two 16 and 3/4. You could do it that way. 16 and 3/4 plus 16 and 3/4. Okay? Which would mean the same thing. So just so we remember how to convert this. So we go times and then add. Okay, so 16 times 4 gives me 64, right? And then I take the 64 and I add 3 to it. So 64 plus 3. So this is converted now to 67 over 4. For those who forgot how to change a mixed number into an improper fraction. Because when you multiply, right? When I'm multiplying this number by 2, okay, you're multiplying this as an improper fraction. Okay, so 67 over 4, and now I'm multiplying it by 2. So all whole numbers, I can put them over a 1, and then either go straight across and simplify it that way, or if you can recognize this, we can simplify this, right? This makes this a 1, this makes it a 2. Okay, so now 67 divided by 2, so 67 goes into 2 33 times, which makes 66, right? Okay, and then you would have left.
Oh, I was like, what? I didn't know.
Yes,
You could have just like added them all, right?
yes, but you still have to get common denominators, because they didn't have common denominators at the beginning, if that's what you were asking. Because one was 11 and 1/4, the other one was 11 and 1/4. Huh?
You can put fractions. You can't
Well,
put
some calculators can.
Okay.
So you're trying to tell me you don't remember how to work with fractions without a calculator?
No, I do. But
Okay.
it's faster. I know,
Yeah.
I know how to add fractions.
Okay. That's what I was doing. But, okay. So that's your final answer for number 40. So next one. Find the area of an equilateral triangle with a side of 8. Okay, flashback from last year. What does equilateral mean? All the sides are the same. Okay. So isosceles would make 2 of the sides would be that, but this one, all of the sides are the same. Okay, what's our formula for triangle? For area? Okay, so 1/2 base times height divided by 2. So one or the other. Same thing. Okay. So base, do we know base? Yes, the 8. Okay. Do we know height? No. So we have to find height. And remember, height is always the one that starts at an angle, okay, and then comes down to the other side and forms a 90. So if it does that, it bisects that side. So that means I need to use my Pythagorean theorem to solve for this, right? So this means that this distance from here to here is what? 4. Okay. So really what we're looking at is this. Okay? 8 is my what? My Pythagorean theorem. Right, hypotenuse. Okay, so we're going back to 4 squared plus b squared, and it doesn't matter which one's the A or the b, equals 8 squared. Okay, and I got to scoot that down. So 4 squared is going to be 16. And then 8 squared is going to be 64. Then we got to do what? Take the square root. Okay, well, move it over. 16 over first, and then take the square root. Which gives you 48. Okay. now the fun comes in. Is 48 a perfect square? Okay. The way they want these answers is in radical format, not in decimal format like you just took a test. So we've got to take a flashback to how do we break down square roots? Okay.
Okay. I think.
Okay, when I break down 48, okay, because I'm taking the square root of that, I can start anywhere, any number that goes into 48. So the first one that jumps into my mind is 6 times 8. Okay, you can start with 2 if you want to start with 2, doesn't matter. I'm starting with 6 and 8. Okay, 6 is not broken down. It's not a prime number yet. So I need to break it down into what times what? 3 and 2. Okay, those are prime numbers, so those get to stop. 8 is not a prime number, so I need to break that down into 2 and 4. 4 is not prime yet, which is 2 and 2. So remember, when you have square root, it means you have 2 of something. Okay, so I'm looking to see how many pairs of what I have, and those ones come out. Okay, so I have a pair of 2's, and I have another pair of 2's. So that means a 2 comes out, and this 2 comes out. What do we do with the numbers when we take them out?
Or you multiply.
We multiply them. It's all multiplication when we break it down, so we multiply when we put it back together. Okay, so I'm bringing a 2 out and a 2 out. You just told me I'm multiplying, which is 4. What is left under that is a prime number? 3, right? It did not have a pair, so it didn't come out. So it has to stay underneath the radical. And we're looking at prime numbers, not the 6, because the 6 are broke down, not the 8, because we broke that one down. We good? Okay, so what did we just find? What part of the triangle?
The height.
The height. Okay, and you said we knew the base, right? What was the base? 8. And what do we do with the base and the height? Multiply. Okay, so 8. So this was my base, this is my height, and then we divide it by 2. So 8 times 4 is 32. So I have 32 rad 3 divided by 2. So whole number with whole number.
16.
Okay. So my answer is 16 rad.
Wait, why don't you divide the rad 3 by 2? Because it can't be.
Whole number, radical with radical. Yeah.
Okay.
Kind of like having 32x. X
Oh,
has to
okay.
be combined with another x. Yeah, good question. Okay, some of these, it'll not be a perfect square, and that's why I did that one. Others, they will be a perfect square. So then you just plug it in, and you're just going to multiply a whole number times a whole number and divide by 2. Okay. But this one I wanted to make sure because they have the answer in radical format, not in decimal format. Okay, last one. So find the area of a rectangle if the length of one of its sides is 6 meters and then the length of its diagonal is 8 meters. Okay, now there was not a, bless you, was not a drawing on here on the notes when you get it. There's not a drawing there, so this is like me just trying to draw a rectangle, and when I write it with the marker, it's not going to turn out. So when you get ones like these, they don't have the drawings for you. Okay, so the length of one of its sides is 6 meters, and the length of its diagonal is 8. Okay, so by putting a diagonal in there, they created what type of shape? 2 triangles, right? So I'm trying to solve for one of the sides, and so we're looking at it as a triangle. So if I were to take that and flip that upright, they gave me, or what's missing? What's missing of that triangle? A or the B square, okay? Because they gave us the C, right? Because that's the one that's always, if I were to flip this up, right? That's the one that's always opposite of that. Okay, so we're going to go 6 squared plus b squared equals 8 squared. So 6 squared, 36. And then 64. Subtract the 36. B squared equals 28.
20,
Yeah.
yeah.
Is that going to be a perfect square again? No. Okay, so what goes into 28? 2 times.
4 and 7.
One thing.
Okay, 4 and 7, yeah, you can do that. Okay, so 4 and 7, which is 2 and 2, right? So that means the 2 comes out and the 7 stays in. Okay, so that's what this one is. So it's 2 rad 7. Okay, we were finding what? Perimeter or area?
Area.
Area. So area is what times what?
The 6.
Right, 6 times the 2 rad 7. So it looks like this. So 6 times 2 rad 7. Okay, so whole number times whole number,
12.
12.
I can divide by 2.
No, because I wanted the area of the rectangle.
Oh, okay.
Yeah. And that is it. Okay. So your assignment, I'll give you the notes, is to finish the rest of them. We'll grade them tomorrow. And then just like normal, con is on there. So just be chipping away at con throughout the week as you progress and finish things. There's no notes on con. Hold on, I gotta grab it. I pulled it out.
How did